This is a demonstration of regression to the mean using a simple Bayesian network model in a genus risk. So the assumption here is that the score that you achieve in a test depends on a combination of ability and luck, where luck has a weighting from 0 to 1, where 0 means that no luck and all ability, and 1 means all luck, no ability. I'm starting off with value 0.3, so basically 30% of what you achieve on a test score is down to luck, the rest is based on ability. And so you can see how we've actually defined your test score here. It's just that weighting of luck and ability. So that's basically the 0.7 times ability plus, in this case, 0.3 times the population average, where population average is a constant that we've defined here, and we just defined that in this case as 50. So we're assuming that the population average test score is 50% here. But this is going to demonstrate regression to the mean in the sense that if you do particularly well on your first test score, i.e. score above average, then you're likely not to do as well on your second score because part of your score was due to luck. Let's suppose that on your first test you get a significantly above average score. Let's suppose you get 75%. The question is, what's the prediction for the second test? And it's saying that your second test, you're likely to get 72%, so it's going to go down. And that's because it's taken account of the fact that part of that better than average score was contributed by luck. Of course, it's learnt that your ability was better than it was before it knew that you got 75% on the first test. But the prediction for the second test is going to be 72%. Now, conversely, what about if you get below average? Suppose we ended up with 30%. What's going to happen next time round? Well, it predicts that you're going to get 32%. You did much worse than average on the first test, you're likely to do a bit better than you did on the first test second time round. And that's a simple explanation and simulation of regression to the mean. It's also important to note that the reasoning goes backwards as well as forwards. So if we know that in test 2 we got a particularly high score, suppose we got 80% in that test score, then it's very likely that we didn't do as well as that on first test score. We run the model. And there you see that the expectation for what we got on the first test score was about 75. Similarly, if we did very badly, we've got 25% on the second test, then because that's well below average, it's likely that in the first test we did better than that. Indeed, we'd have expected to have got about 30% on that one. Of course, if this, let's say, was incredibly low, I mean, let's say 0.001, so there's almost no luck, then taking the same example, if you got 30 on your first test score, what you're likely to get on the next one? Well, you're likely to get 30. So it doesn't change. And similarly, if you got well above average, 75, then that's basically what you're likely to get next time round. Here's a different example with football managers. So this is the observation that when a team sacks a manager on the basis of them having a very poor run of results, it's usually the case that when the new manager comes in, they're much more likely to win than they seem to have been before. And the assumption is always that there's some boost from the new manager's better. But actually, this is simply an example of regression to the mean. I mean, there will be some new skill, new motivation component, but it's the same notion that luck is contributing to that inevitable improvement from a bad run. So let's suppose in this case, again, we'll give luck a weighting of 0.3. It's a slightly more complicated model here, but the same principle is involved. Suppose we observe a run of 10 matches. where, let's suppose they only won one. The assumption is that you either win or lose matches. There are no draws, there's simplicity here. So you're on a very bad run, having won just 1 in 10 matches. You sack the manager. From these observations, we learn the win probability, which takes account of both the skill level and takes account of the luck weighting. And what you can see is that the win probability, it's not as bad as you'd expect from 1 win in 10 matches. So there's actually almost a 30% probability that you'll win the next game. And over the next, let's say, 10 matches, we can see the expected number of victories. You're likely to win 3 or 4 matches rather than the one in your previous sequence.